We had a little bit of trepidation when we decided to do the EMEA Summit right after the ISE show about doing it on a Saturday, because the Europeans tend not to enjoy things on the weekends other than family time. But we very much appreciate the fact that you've all decided to stay at least an extra day with us. So you have my deepest appreciation and the appreciation of the entire team. A great number of people had a hand in getting this to where we are today. And I'm going to acknowledge a couple of them. One of them is Peter, he's right up here. Peter is the chair of the EMEA committee for the Z-Wave Alliance and is instrumental in reminding us all the time about how important places outside of the 48 states, I only say 48 states there, out of the United States, and how important the rest of the world is to the Z-Wave Alliance, and has been since the very beginning. And there's Sergey, who most of you hear from on a regular basis, also has been a great advocate. See, you snuck in the room. This is what happens when you sneak in the room, you get pointed out. Has also done us a really great service in reminding us the importance of the Z-Wave Alliance being a global alliance. And we're very lucky and happy to have them here. Again, the number one thing that you're going to hear from me during this summit is the word participation. I know that we have a lot of technical people in the room, and these summits always slant towards the technical. But it is very important, both in the technical and the marketing, that you get involved in the alliance. As we talked about last night, an SDO, a Standards Development Organization, has the word development right in it. The idea of being a development organization very specifically is that we, as the member companies, drive the initiative. You have a new idea, you have a concern, you have an update, you found a bug. Any of those things are driven by the members themselves. The manufacturers no longer control the intimate details of what goes on within the standard, the members do. 2024B, our latest version, has just been released. There's all kinds of press releases about it, and it contains specific updates that were worked on, sponsored by, and brought to fulfillment by members. Yes, obviously the manufacturers have the software and they make some changes, but because we are now an open standard, there are lots of people doing lots of things within the Z-Wave Alliance. And so it's important that you all remain participatory in this event. And the fact that you're here means that you are passionate enough about it to take time out of your busy schedules and your busy businesses to spend some time with us. So, the Z-Wave Alliance, as many of you have heard, is in fact growing. There is a famous quote about the early death of a person is greatly exaggerated. I can tell you that the rumors of the demise of the Z-Wave Alliance are also greatly exaggerated. As evidenced by the people in this room, as evidenced by the activity online, as evidenced by the number of devices that we have certified over the last year, the new initiatives, the new software, the new updates, all of it is indicative of the fact that the Z-Wave Alliance isn't going anywhere. We've added multiple silicon vendors. There are more silicon vendors to be added. We're not stopping here. We're not stopping at 2. We are going to continue to grow. The board of directors meets on a very regular basis about initiatives outside and beyond the 4 walls of the alliance. We have conversations with other alliances. We have conversations with other organizations. We have conversations with other industries. Obviously, for the last number of years, the residential business has been very important to the Z-Wave Alliance, both here and abroad. But that's changing. I was in Japan in October, and I met with a Z-Wave member in Japan who is revolutionizing the care of the elderly in Japan by using Z-Wave devices to monitor and understand how those people are interacting with their environments. And it's a healthcare certified in Japan, a healthcare system certified that uses Z-Wave as its communication backbone. I actually attended a healthcare trade show in Tokyo, where there were many different companies showing many different ways, and this gentleman had a very extensive booth. He's got some really cool tech that he has decided to use Z-Wave as the communication backbone for it. And that's just one example outside of our traditional sort of venues, right? Traditional residential, traditional American, traditional people speaking about different topics. We're going to cover things like cybersecurity. We're going to talk about the evolution of the Z-Wave standard. We're going to talk about future stuff. You're going to have an opportunity to complain to me because I want to hear your complaints. Part of my job is understanding where the problems are so that we can help you fix them. The number one thing that you're going to hear me say beyond participate is, how can I help? The Z-Wave Alliance stands ready to help each and every one of you through the process. Whether it's a technical problem, a marketing problem, a design problem, a product problem, we're here to help and assist. You want to get the word out about your products, we're here to help you. You want to develop something new, we're here to help you. You want to meet the next manufacturer who can help you build something, we're here to help you. We're not here to take sides, we're not here to be favorable of one or the other. We're here to help grow the Alliance, we're here to help grow each and every one of our members equally. And I have strived to do that since my time here as the chair of the Z-Wave Alliance. So, the other thing is, this is your summit. This is your opportunity. Interact, not only with one another, but with the lineup of speakers that we have for you. We have a wonderful lineup. Peter and his committee have put together a really, really great agenda for us, and so we're looking forward to you guys all experiencing it. Ask questions, get involved, participate. I promise you will get much more out of it if you raise your hand than you will if you sit and just take notes. So, with that, did I forget anything, Jen? We good?
I think we're good. I'd say the only thing is the QR code.
The QR code,
Yeah,
right.
bring that in. It has the full agenda. It also has the Google Drive link so you can upload any photos. If you do put any of your photos on social, please tag the Alliance.
Okay.
There will be lunch.
There will be lunch.
That's very important.
Exactly. Most important meal of the day. Okay. Now that you'll have breakfast. All right. With that, we're going to bring up. There he is. Come on up. We're going to bring up our first speaker who's going to talk all about GS, right? Exactly. So, without further ado, Dominic, we're going to let you introduce yourself, but I'm going to say a little something about the organization that he's with. And unfortunately, Paulus is not here with us, but we are well represented by the Novocasa team, and I thank you very much for your participation, for your sponsorship. Novocasa is actually the newest board member of the Z-Wave Alliance, and we're very excited to have them and the Home Assistant folks as part of the group. I won't steal too much about what he's going to talk about, but I can tell you that Home Assistant is number 2 on Reddit at this point. Is that what I was told? No?
I think you mean it's number 1 on GitHub now.
Yeah.
Okay.
It is the first one.
Yeah, it's now the first one.
It's the first one?
Yeah.
GitHub, yeah.
Okay.
Yeah, so we're the top open source project on GitHub. We had over
On GitHub.
21,000 contributors
I had
last
so
year.
it's GitHub, not Reddit. All right. With that, please. Thank you very much, everybody. Welcome.
Can everybody hear me okay? Great. Thanks for having me. I start with a small introduction. Some of you might know me, some don't. My name is Dominic Kriesel. Some of you might know me under my GitHub handle, because I'm pretty active there. I actually stumbled in the smart home world more or less by accident. I was doing a little side project with a friend I met at university, had to do with Z-Wave automation stuff. At that time, not with Home Assistant, but with a lesser-known home automation project local to Germany. Worked a bit with that. Worked on a few simple integrations for that, like Wi-Fi plugs, the IKEA hub, Bluetooth a bit. But I also did Z-Wave. Built my smart home with Z-Wave at home, and at the time that was with OpenZ-Wave. And with OpenZ-Wave, I mean the project that's public on GitHub, not the one we call OpenZ-Wave here. So sorry, I have to poke a little fun there. And I became more or less unhappy with that because development was slow and I had devices that didn't work with it. And so I thought to myself, let's just do it myself, because how hard can it be, right? Well, it's 7 years later now. I'm still working on it. I'm now talking here, so I might have been a bit naive there. So the side project I started back then, of course, is Z-Wave.js. I've brought you a little timeline, how it started, how it went. Start of 2018, I had my first commit to GitHub. I checked that. Took a bit longer to get it running than I expected. The first time it ran in production was end of 2019, so about 1.5 years later. But it didn't take long to get some traction. Like 1 year later, the maintainer of Z-Wave to MQTT, that was at the time one of the main ways to get Z-Wave into Home Assistant, also got frustrated or was frustrated enough with OpenZ-Wave to start looking for alternatives, contacted me. And just 2 months later, a new project called Z-Wave.js to MQTT was born. It's now called Z-Wave.js UI for simplicity. And it didn't take long for Home Assistant to jump on board. Not much later, Z-Wave.js, Z-Wave to MQTT, the old one, was deprecated. Home Assistant was on board. And if you look at the timeline behind me, over the time, more and more projects started migrating. First, GLM, it's a small home automation platform local to Europe, I think. Domotic started using it, and in April of 2022, I then started at Nabukasa. You would say the company behind Home Assistant. It's not 100% true, but it's the one pushing it forward. So then I started working on Z-Wave.js full-time. Also maybe interesting, there's a name you might have seen before. Didn't take long for HomeSphere to jump on board. I would say one of the oldest Z-Wave companies. They told me they still had Visual Basic Code running in production at the time. They started to migrate over to Z-Wave.js. Their new plugin is based on Z-Wave.js, and they are all in now with that. And over the time, more and more projects started migrating over. OpenHab was one of the later ones who had their own Java implementation. And somewhere end of 2022, the project I set out to replace was officially unmaintained. So the original OpenZ-Wave is dead for 2 years now, almost. So 2 more things to highlight. It was already mentioned. Start of 2024, Nabukasa joined the Z-Wave Alliance with one goal is pushing Z-Wave.js further and getting it to certification. But also end of 2024, Paulus joined the Z-Wave board. So that's a good thing. And somewhere in between, I joined with Z-Wave.js, the Open Home Foundation. You've seen the name on the tags and out there. So I want to say a few words about what that is. It's a Swiss non-profit organization. It fights for the 3 pillars of what we call the open home. It's called privacy, choice, and sustainability for the open home or for the smart home of end users. And to do that, it supports critical standards that support local communication first, like Z-Wave, like Zigbee, like Meta and others. And since then, it has taken ownership of over 240 smart home projects, standards, drivers, and libraries, including Home Assistant, which means Home Assistant and those technologies are no longer for sale. They are protected by this Swiss foundation. And what it also does, it funds external projects that align with their vision, like Z-Wave.js, which is part of why I joined. Where might have you seen Z-Wave.js before? Like, of course, Home Assistant, it's built with Z-Wave.js in mind, but many of the other popular open source smart home platforms like iBroker, where I started, GDM, Domotics, OpenHab lately, and like I mentioned, HomeSphere have started moving over. You might have seen it last year at the Austin Summit. There was a presentation where the engineers showed how they use Z-Wave.js in their development. Like they were automating tests with end devices, figuring out how the SDK behaves. So maybe some engineers in your companies are already using it without you knowing, maybe. Who knows? You might have seen blog posts from a certain Z-Wave influencer. I've seen him before here somewhere. There he is. Those heat maps and range testing, that's all done with Z-Wave.js. So we work together. I'll say a few words later about that, but essentially all the data collection is done with Z-Wave.js in just a few lines of JavaScript. You might seen a few videos on YouTube. There was a bit of controversy in the last years, but there was a series of videos by Linus Tech Tips with a huge reach. Millions of subscribers and millions of views on their video, and they did a whole series about how they built their smart home with Z-Wave. and they were using Home Assistant with ZWF.js. You might have seen a recent video from Silicon Labs about the range testing stuff. That's ZWF.js in action. So I was pretty happy seeing that. Yeah, and with all these examples in mind, what is it actually? I've tried to put it this way: it's standards compliant, community driven, open source ZWF device driver that runs almost anywhere. To go a bit more into detail what that means, it's standards compliant as opposed to projects like OpenZWave back in the day, because I started after the ZWave specifications were made public, so I could start development from scratch with the specifications in mind. I could read them, I could see what I'm doing is correct or is not correct. Mostly, of course, I found bugs and had to make changes, but I could build towards a goal where I knew it would be correct. And that also means we are working hard on it to be able to certify it soon, which means you could be able to use it yourself in applications. Community driven is it's open source. Everyone can contribute, be it bug fixes, be it new features. For example, our long range support was initially contributed by a user. I just made the last final touches, did some consistency fixes, but the main work was done by a user who wanted long range in his ZWF.js based smart home, and they set out and did it. And a big thing of the maintaining is device configuration files. We use those to identify which devices we are talking to, because all we get is the manufacturer ID, product type, just numbers. Users don't know what those are. And we use config files to map those to names, like which manufacturer is it, which device is it, how it's called, and so on. Which config parameters does it have, which association groups, and so on and so on. There are so many devices we cannot test everything, so we really rely on the community to provide those, to test those in their own devices with their own smart homes. And that's really easy to do if you have like over 100,000 users with millions of devices. And this unlocks an immense potential for development because, like I mentioned before, ZWF.js is what we call open source, truly open source. Everyone can go to GitHub. Everyone can look at the code for free, take it, do whatever they want with it. We have a very permissive license, the MIT license, which allows you to do what you want. You don't have to attribute us, you don't have to pay for anything. Just use it, build something cool with it. Maybe tell us if you want to share, I'd be happy to hear that. And so it opens a lot more eyes to spot potential issues, for example, compared to if you have, say, proprietary hardware abstraction layers where you get a release of binaries every 6 months. Nobody can look at it and figure out what's wrong. Maybe as an example, I just had a chat this week with an engineer from a pretty big law company. They are not here right now because they're US based, but they were building a small tool with ZWF.js, and they were running into an edge case I hadn't seen before. Took a couple of messages on Discord, 10 minutes later they knew what was wrong, had a little workaround locally, and moved on. I knew what was wrong, I knew what to fix, and they could go about their day and work on what they wanted to work on, as opposed to waiting months or weeks for a release. And my last point here is it runs almost anywhere, and I'm going to show that on the next slide. Maybe some to understand what it is. If I say ZWF.js, I normally mean the Node ZWF.js project, which I often also call the driver, because it's the thing that talks to your serial port, that does all the heavy lifting, encryption, command queuing, figuring out what goes where, which commands to correlate, and so on. And it also provides access to a firmware update service I'll talk about later. And applications will want to use this driver in their application. So there are several ways to do that. But because it's based on Node.js, it runs everywhere that can handle the Node.js runtime. That means Windows, Linux, Mac, probably some other platforms that are lesser used. You just need a bit of RAM, so you won't be able to run it on like a tiny ESP, because Node.js alone needs like 50 megabytes of RAM, and depending on what your application needs, there might be a bit more. But also very recently, I just edited my slides this morning because I finished it, the support for that this or last week. You can also run it in Chrome-based browsers. So you can build web tools with it. For example, a firmware flasher where you can tell your customers to go to this site, plug the device in, press this button, and it will update the firmware. All running with ZWF.js. If you want to go a bit more traditional, there are several ways to do that. You can use an application also based on Node.js and just import the module and use it directly. You can use, for example, Node-RED plugin. There's a community-driven Node-RED plugin where you can automate in Node-RED based on ZWF.js. There are several language-specific wrappers, one for .NET, one for Python. The Python one is actually the one we use in Home Assistant. Those talk to a WebSocket wrapper we call ZWF.js server. It's just a small binary that hosts the driver for you, but exposes the whole API via WebSockets. So you can have like ZWF.js running on one computer, your application on another one, and just talk to the driver via the WebSockets. And another option is ZWF.js UI. It essentially adds MQTT support to ZWF.js server plus a whole UI on top of it, like node management and some installer tools I'm going to show later. A lot of stuff on top of it, like pre-built UI. This is not going to be certified because nobody's going to pay for it, at least not right now, but it can serve as a good basis for your application or just any project. I forgot to mention Docker is also an option, of course. You can run Node.js in a Docker container and also run where you want, especially. So what can you do Z-Wave-wise? This isn't a complete list. I just want to highlight the most important things. We have most widely used command classes are supported. Actually, we counted yesterday because there was a little bit of competition going on. Right now, it supports 64 command classes, which puts it, I think, pretty high on the list, including security S2 and S0, smart start, long range, and you can control almost anything about the commands you want to send, including if you want to do single cast, multicast, broadcast. Supervision, I forgot to mention here, I can configure that. On the more higher level side, you can do network management, you can do route management, like assign priority routes, priority return routes, have the controller configure new routes, you can manage associations, configure the radio settings, and do OTA and OTW firmware updates pretty easily. So what can it do for you? I think that's most interesting, I guess. As mentioned before, we are working hard on certifying ZWF.js very soon. Our plan is currently this quarter, or at the very least the next quarter. And after that, you will be able to build your own host application based on ZWF.js instead of using Zip Gateway or Unify or whatever you've been using before. And that goes without additional certification costs. And this is because the Open Home Foundation is paying for the certification of ZWF.js, including the S2 part, because we are not using a traditional S2 implementation. We have to certify that too. And if you are using ZWF.js, that doesn't apply to you. Of course, since we are bearing those costs, and if you want to use ZWF.js, would be appreciated if you chime in there. If you want to do that, talk to us later, but there's no obligation to. What's also interesting, you can do tests against the second implementation. That's quite a bit different from the others you've traditionally seen. Like, there will be slightly different behavior in some cases. For example, we don't use the ZWF XML to define command classes and commands and so on, how they are structured. We were, I think, the first to use supervision by default for set commands, for example. Instead of just sending a set and getting the state back, we use supervision, and that has highlighted quite a few bugs in existing devices. For example, we had a lock that would, after we controlled it, it would send reports every second until the battery ran out. They use ZWF.js now for testing. That bug is gone. Incidentally, we had another lock, also with problems with supervision. At first, it didn't seem or it seemed to work normally. It reported the status back and everything worked. But then they had reports of Home Assistant users only having logs with abysmal battery life. There was no communication. It wasn't easy to figure out what it was. It turns out the logs didn't go to sleep after sending supervision reports. So they were awake the whole time and were just draining the battery until it ran out. And that hadn't come up before because nobody was using supervision in production. Aside from that, we also found bugs in the CTT. Some were actually bugs in ZWF.js, but they had unexpected behavior, crashing the CTT tests. Both are fixed now on both sides. And there was one case where the S2 test in CTT ran into a case where that hadn't come up before, where I think it was sequence numbers or nonsense. I don't remember exactly now. But yeah, we found things that had gone unnoticed for years before. We've worked with MKLogic to figure those out, so thanks for the quick response there. But it just shows how having a second implementation of something can help find bugs that nobody has seen before. You can do automated stress testing, for example, like send hundreds of commands to a device and see how it behaves if something breaks down, if something in the ZWave stack doesn't work. Or like the folks at the ZWave Summit last year did, automatically comparing different firmwares. Like install one firmware, do tests, install the next one, do tests, and everything fully automated. Another example you can do is like prototype new command classes. I mentioned before, I was working with Eric on the range testing tools he was using for these nice heat maps he's generating. I would boil it down to, we had one video call, a few emails back and forth, and maybe 2 days later there was a script with 200 lines of JavaScript code where most was set up, like setting up the port, setting up the security keys and so on, and the range tests were working. We at Nabucasa use it for developing new hardware features, like we have a ZWave controller in the works, you'll see it very soon, and have proprietary serial AP commands, which I'm testing with ZWave.js. If you want to see that, I can give you a demo over there later. Yeah. And how to get started, I want to give you a short introduction. There's documentation available. If you want to look at it, just scan the QR code. The basic outline of a simple script example, for example, the range testing script is you configure it, like the port, security keys, everything else you might need. You set up event handlers to react to what comes in from the network. You start the driver, as I call it, and put your business logic in. And that's it. I'm going to show it. Just bear with me while I sort my cables here. Hope everything works, because as always, live demos are dangerous. So what I have here is a ZWave controller, a ZWave end device with color support, and a simple dev kit with an LED on board. So how do I switch? No. There we go. Yeah. Can everybody read that, or should I make it larger?
Can we turn off the light?
Oh, that would be good, yeah. Brighter, I'm not sure. Can you turn down those lights somehow?
Try it.
Oh, perfect, perfect. Okay, so what I'm doing here, I'm just going to go through the setup code with you. It's not too much to look at. So the first thing we do is import the driver from ZWave.js. This is just a Node.js script. I've also imported some utilities we might need later. You might not need them, you might need them maybe. Then here we set up the driver, like the serial port, and configure all the security keys for S2, S0, long range. Then we wait for the driver to be ready, that it does a bit of initialization with the serial API. When it's done that, it tells us that it's ready, then you can continue. And what we then do is for all nodes to be ready. So we have 2 end nodes. We wait for all of those to be ready to interact with, so we know everything about them. If I hadn't interviewed them before, they would now be interviewed. Everything they can do would be queried for us. You don't have to do that. And once that happens, we jump into the main function below. And the one thing we do is start. This is just for shutting it down cleanly when I exit the script. And the main function for now is just logging that all nodes are ready. So what I'm going to do now is just run it once so you can see. So it starts up, queries a bit stuff from the controller, and then here, down up there, it printed all nodes already. So we would be ready to continue. The first thing I want to do is just, there's a little LED on here, I'm going to make that blink. Nothing major, I think, but just to show you how easy it can be. So the first thing we want to do is we need a node to interact with. That's awkward with the mouse here. So we need the node, and for that we, oh, perfect. There's just a little thing to make TypeScript happy. I'm going to use get or throw, so we know the node exists. Otherwise, the program would crash. But you can also use get. It would return undefined if the node wouldn't exist. But I know it does, so we just get a reference to the node number 2, which is this device here. What we're going to do next is like just make it blink 10 times or so. Oh, that's easy. So for you to understand what I'm doing here is the first line accesses what we call the command classes API. So every node has command classes, as you know, and we have a simple API built on top of that where you can say, okay, I want to use the binary switch command class and call it the set function. In this case, when we are if we have an even iteration, we want to set it to 0 or to false or to true, so on. And if we have an odd iteration, we want to set it to off, so essentially blinking. And after each iteration, we wait for a second. And I'm just going to run that. And you want to look at, there's a little orange LED up here. I'm not sure if you're going to see it from the back. I'm trying to hide the other LEDs. And it should start blinking now in a second. Do you see something? No. Live demo, nice. Let me check what. Oh, no, oh, I didn't save. Okay. Forgot to save the script. Let's try again. Oh, it blinks. So, to go a bit more complicated, we can also do that with color. I'm not going to type all the thing out. I've a bit of script typed out before, so I'm just going to copy that, but I'm going to explain to you what I'm doing there. You don't have to watch me type JavaScript code for too long. Essentially the same thing. This time we have a long range node, EU long range, with node ID 264. This is what we get in the line here. I've defined a set of colors with red, green, and blue. And then I have a loop where I go through that list, and every iteration I set a different color on the device. Wait a quarter of a second, and in the end, I'm going to set it back to a low green, so it doesn't blind me here. I have the device here. These are probably a bit easier to see in the back, and I'm just going to run that as well. Prepare for a bit of disco. And that would work for other LED colors as well. So we just have an RGB LED, but there are many like other color channels. You can do white, warm white, cold white, and so on. That all works. Most of it works by name, or except I think like index color. So as you can see, the goal is to have like the API be more or less human readable as well, easy to understand what it does. I have a couple other examples, like we might want to get the state of a light. This one has, I think, a button to toggle. Oh, it doesn't, okay. Because right now all we did is control it, but we can also read back information. I'm just going to copy that, you don't have to watch me type it. It's easier that way. So, of course, go back to node number 2. So what I'm doing here is, again, use node number 2, then use the binary switch API to get the current status. This one is a bit more complicated because if you hover it, it also shows you which types you get back. It gets back current value, the target value it's transitioning to, maybe or maybe not, depending on if it's transitioning, and you might get back a duration, how long that takes. Right now, all we are interested in is the current status. As with all GET requests, there might or might not be a response. If there's not a response, you won't get a state back, so we are checking here if we have a state or not. We are checking if the current value is true or not, and then log the corresponding log in the console. I'm just going to run that as well. Right now, the orange LED is off, so it should log this thing is off. Just going to run it again. Starts up, queries everything. So as you can see, we got a report back. Also, the logs I built them from the ground up to be. We should stop that and scroll up a bit. I've been reading a lot of logs since I wrote the WebJS. Millions of lines, gigabytes of log files I've gotten from users, and so I made sure if you look at the logs and you know what you're doing, you understand what the log is. So everything is spread out for humans to read, which command classes you get back, which properties they are, what the current statuses are, how it's nested and everything. So you can see we got back a binary switch report with security encryption in S2 authenticated key. The current value is false, it's not transitioning, and our log also reflects that. And yeah, I guess to save a bit of time, I'll skip the last one. Any questions so far for the code? Otherwise, you can ask me later too. That's fine. So let's get back to the presentation.
Yeah, I do have a question.
Yeah?
I assume you already handle unsolicited messages
Yeah.
as well?
We do, yeah. I had an example for that, but time is too short. So you set up event handlers for that, and you get notified when something comes in that doesn't belong to like a GET request or that isn't handled elsewhere. The application gets notified. So, with that in mind, I have a few more things I want to talk about. One thing is our firmware update service. I teased it earlier. This is the service we built to make sure our users have the best experience and a secure smart home by having access to firmware updates very easily. It's available to all users of CWJS, so you don't have to be using Home Assistant. You can use another application, you can build your own and use it. And right now we have 8 manufacturers contribute updates there. For the end user, it will look like they get a notification, for example, in Home Assistant, hey, this device has an update available, do you want to update? Users can click. It will download the update from the manufacturer server, install it on your device, and it's updated.
So it's
CFJS right now, have you thought about making that service available to other?
There isn't a public API. Right now, the thing is, I'm paying for the hosting costs. So if someone wants to use it at a larger scale, it is possible, but we need to figure something out. So I don't pay your bandwidth. Like I said, currently we have those manufacturers on board. For about 200 of their products, we have those updates available. Users very much love it. So if anyone of you might be a candidate for that list and isn't on there, talk to me. We would love to have more on board. A bit more in depth for technical things, we also have NVM migration tools built in. Users like shiny new things, but swapping controllers like from especially 500 series to later series is a huge pain. Especially if you have users with like 50 to 100 devices, historically they had to unpair them all, swap controllers, pair them all again. If the cable's somewhere in the attic or something, this is a day's, if not several days work. And what CWFJS does, we read the NVM backup, pass it into a format where we use JSON as like a human readable form for that, do some modifications to it. For example, if we migrate from one controller to another, we know some things about the target controller we need in this representation, modify it, and then serialize it back to the NVM binary format of the target controller, including SDK version, NVM size. For example, the difference between 7 and 800 series NVM sizes is respected, and like the changes between SDK versions and so on. So what you can do is swap freely from 500 to 700 to 800 series and back, with a small limitation that 500 series is limited to SDK 6.61 and higher, because I don't know how the NVM is structured in the older ones. That was enough pain to reverse engineer already. I know we have a few installers here. This is a screenshot from CWFJS UI. We have built in a few installer tools. Those are inspired by what's available in PC controller, but it runs everywhere, like Linux, Windows, Mac. The left one is what we call health check. You just have the controller and the device ping each other, and we see how many route changes there are, how good the quality is, if there are any failures in communication. And the right one is more actual communication, like we send basic set commands with supervision and encryption back forward in a high frequency. So we know if there's just the least bit of corruption in the communication, and collect statistics like RSSI, latency, and so on. So there are built-in tools available for testing how strong a mesh is. We also have Sniffer, web-based, on web UI-based. It's not running on the web yet, but I'll be working on that. Right now, limited to NCP sniffer support, so no PTI sniffer, but shouldn't be too hard to add that too. So you can do all that from the same UI on Linux as well. And I think one thing that might be most interesting for some developers is we'd also do device emulation. Like a few versions ago, I started using CWFJS to test CWFJS. And what we do is we have like a component that emulates how a controller behaves, that emulates how nodes behave, and exposes that via a virtual serial API. So the application doesn't know it's talking to a fake port or a fake stick. And you can test how the application behaves under certain conditions. Like if a response that should be coming is not coming, or the controller gets stuck and does not respond anymore, like we had in some SDK versions recently. We use it to test ourselves, like we have integrations tests to make sure each scenario is handled correctly. Home Assistant started using it for doing UI tests. And what you essentially do is there's a standalone component you can run. It exposes the TCP port, and you can define how it behaves, but you can also use some of the predefined behaviors. Like we have predefined behaviors for getting the supported serial API commands and so on. So a lot of stuff is already supported. And if you need special behavior, you can program that yourself relatively easy. And since I'm right at the end of my talk, time's out, just a small hint, we also have the ability to send custom protocol commands, so you can do stuff the stack won't let you do. And some web-based tools like a QR code generator you can use to get from a DSK to a QR code that tests CF long range with the QR code and so on. And we have an NVM editor that's online where you can try out this conversion I told you about earlier. Yeah, that's it for me. Thanks for the attention, and if there are any questions, let's ask me.
All right. Do we have any questions? There's lots of questions. Good. Everything all good. I turned off the mic so I didn't bother anybody. Now I can't turn it back on. I'm sorry. Is the red one? Ah, okay. All right. I'll hand this out. Still raise it. Okay. Questions? Still.
Yes, thanks, Tony. Just for the installer tool, where is it? Is it something it's an add-on to Oma System?
So Home Assistant has two add-ons you can run. They're called ZWave.js and ZWave.js UI. ZWave.js is the official one that's supported. It's a bit easier. It lacks a bit of tooling that most end users might not need. And there's a community add-on called ZWave.js UI, and that includes all of that.
Okay, so but I do UI and I haven't seen that installer command.
You have to go on the network map and click on a node, and then you can do these tests for this node.
Okay, and do you ping the nodes and report back some of the millisecond values and things like that?
Yeah. The one is just pinging, like we ping the node a few times, measure the background RSSI, figure out how much of a margin there is. And on devices supporting, how's it called? Power level CC, we also instruct the device to ping us back. So we get information about the reverse route as well.
Okay. And for the association, we agree that Z-Wave JSON and Z-Wave JSON UI, the UI version has the association set up and
It does. It does, yeah.
It's not on your roadmap to include that in the regular.
As far as I know, it's not on the roadmap for the other one.
Okay. Thank you very much. And nice job.
Later.
They can do it like
Yes.
Any other questions?
Yeah, so great stuff with the ZWave.js. It's really cool. I heard you mentioned proprietary commands in Zero API.
Yeah.
Which I do not like as chair of the open source group. So any plans on contributing some of that to the lines?
So the proprietary command I talked about is controlling this LED on a controller. I'm not sure if it makes sense for the open source stack. If there is, I can surely contribute that back. But I guess it might need to be a bit more generic for that.
Yeah. It
So
needs to be generic.
we need to
But
figure something out.
There are requests for Zero API commands for controlling I/O pings and stuff like that. So
yeah, it would be great. Yeah,
might be
would be great.
for the community.
We also have a sensor on board where I need to get readings back. So, but if there's some interest in that, we can figure something out. Definitely.
Anybody else? Yes. Please.
All right, so coming back to the EMEA migrations,
Yeah.
we have a lot of controls, and so far when we have tested the EMEA migration, it did a full interview of all of the nodes. So will there be any plans to like leave out the interview when you're migrating from a controller to another one?
I think there's a reason we do that, but I'm sure we can work out something. If you are sure you don't need it, then you can do that as
That
well.
would be really nice because the re-interview does a lot.
It takes forever.
and
Yeah.
that can cause issues.
Yeah.
All right, thank you.
I'm sure there's a comment somewhere in the source code why we do it, so, but I don't remember right now.
So I'm gonna there more, if that's more question to everybody else, I can yell, don't worry.
Because I just handed the microphone to the next person,
Oh,
so,
sorry.
yeah, that's it.
I really like that firmware hosting, right? So I would encourage all the manufacturers to put it there, and I will make Avi to pay for it.
So right now,
No, I mean, the board, Zero board will be absolutely
should,
interested,
yes,
right?
the
So-
alliance should put it, no, it's part of the STI, absolutely.
Yeah.
so right now
Same.
the manufacturers host it themselves, but it really makes sense. I think the CSA has, or Meta has something like that
So
already.
let's have that conversation.
Yeah, let's do that.
Because we as board would be really interested. That was an initiative that we had for a really, really long time. There was just nobody spearheading it. And if there's a public API, why not?
Why not?
A couple $100 a year.
It's no big
I
deal.
don't think it's gonna be even more than that.
No, it's no big deal at all.
Sorry.
Now our official question, please.
Dominique, I have a question on S2B2. So I know that you have been following the specification. Do you have any plan or any schedule on how you will take a stab at implementing S2B2?
I've actually just been waiting for the specs to be finalized.
Aren't we all? I mean, yes, they're being worked on as we speak. Yes.
But if there are no changes to the host side of things, we talked about yesterday evening too. It should be a day's work or so, and then we can have it in a week or so.
Yeah. On the specification side, I think it's
Yeah.
done, but yet I see some.
I think the hard part is controller side implementation, right? Yeah.
Yeah.
Okay. All right, think we have time for one more? Nope. Good. All right. Well, thank you.
Thanks for having me.
Thank you, thank you.
Good stuff.
Really great stuff. Very, very interesting. Thank you. All right, so I'm going to make an executive decision. We're going to take a 10-minute break, refill your coffee cups, or make room for more coffee, whatever you need to do. But we will get started at 5 after 11. Sergey, you can, that'll give you time to get set up. 5 after 10. I know, you can ask if I can read the watch. Yes, okay. 5 after 10. 5 after 10. This will give Sergey some time, so please, we'll do some bio breaks and some coffee runs. Thank you very much, everybody.